Video about the geometric proof of the derivative of sine. We need some prerequisite information, and one of them is that sine of alpha plus beta, so this is the addition formula for sine. The other prerequisite information is about limits. So if we have that the limit of a function as x goes to a is equal to L, and we have another function g of x, and the limit is m, then if we have the limit as x goes to a, the addition of these functions or subtraction of these functions would be and if they are factors, then the limit can be split up. And if it's a fraction, you can split up limit, but it's important that the limit of the denominator is not equal to 0. So we can start with the definition of the derivative, and it's that the derivative of f with respect to x is equal to the limit as h goes to 0, f of x plus h minus f of x divided by h. Now our function is sine of x. So we can plug this in to the definition, and we would have the derivative of sine of x is the limit of h go to 0, sine of x plus h minus sine of x divided by h. Now we can simplify this by expanding this with the addition formula for sine, and we would have now we can factorize the sine of x. And now if we split up these fractions, we would have so if we remind ourselves of the rule for limits and addition, we can split these up, and we note that this factor doesn't depend on h, so we can move it outside the limit, and this factor doesn't depend on h either, so we can move that outside the limit. So we would have sine of x, the limit as h goes to 0, and now to summarize, we have that the derivative of sine of x is equal to sine of x times the limit of h going to 0 cosine of h minus 1 divided by h plus cosine of x times the limit as h goes to 0 sine of h divided by h. So if we find these two limits, then we are guaranteed to find the derivative of sine. So if we call this limit number 1 and this limit number 2, we can work on these two limits separately. So let's start with number 2. So we have the limit of h going to 0 for sine of h divided by h. How we're going to find this limit is by squeezing it in between two other values. So if we look at the unit circle, so if we draw a ray from the origin to the periphery with an angle, then we can find three areas. One is the triangle going from periphery, the end of the ray, to the periphery at y equals 0. Another area is the circle sector. And the last area is if we extend the ray and drop down at y equals to 0. So if we write out these areas, the first is the inner triangle, which has a height of sine of h. So the area is equal to r times sine of h divided by 2. So we have sine of h divided by 2. So this is the base, which is 1, and the height is just sine of h. And for the circle sector, we have an area which is equal to r squared times the radians divided by 2. And here r is equal to 1, so we have h over 2. And this is the middle area. And for the last and biggest area, we need to note that if we have a triangle like this with base 1, which is the case for this triangle, the base is 1, and we have a height, let's call it height, and the angle is h in radians, then the tangent of h is equal to height divided by 1, which means that the tangent of h is equal to the height. So for the yellow area, we have that a is equal to r times tangent of h divided by 2, and r here is 1, so we get tangent of h divided by 2. And now we need to note that the red triangle is the smallest triangle and the smallest area. The blue sector is the middle and the yellow is the largest area. So we can write this like the red area is the smallest, the blue area is in the middle, and the yellow area is the largest. And if we write these out, we have that sine of h divided by 2 and h divided by 2 and tangent of h divided by 2. Now we can multiply all these by 2. We get and we can write out what tangent is. We get that sine of h and sine of h divided by cosine of h. Now if we divide everything by sine of h, we would get 1 h divided by sine of h and 1 over cosine of h. Now taking the reciprocal of all of these, we would flip all these inequality signs. We would have that 1 is the largest, sine of h divided by h is in the middle, and cosine of h is the smallest. Now if we look at these boundaries, 1 will always be 1. Cosine of h, if we let h go to 0, then cosine of h would just go to 1. This means that in the limit h goes to 0, sine of h divided by h is trapped or squeezed between 1 and 1. This means that the limit as h goes to 0, sine of h divided by h is equal to 1. And this is our yellow limit, this second one, this one. Now we can continue with the blue one, cosine of h minus 1 divided by h. What we can do is multiply by 1, and a smart one, let's multiply by cosine of h plus 1 divided by cosine of h plus 1. This is equal to 1, so we're not changing the limit, but it makes it easier for us. So if we multiply through, now we can use the trigonometric identity, which says cosine squared of h plus sine squared of h is equal to 1, and we get that limit as h goes to 0. Here we would get negative sine squared of h, and the denominator is still the same. Now we can split these up in a smart way. So we would have limit as h goes to 0, sine of h divided by h times sine of h divided by cosine of h plus 1. Now if we remember the limit of products, we can split these up. So we will have the limit as h goes to 0 of sine of h divided by h times the limit as h goes to 0 sine of h divided by cosine of h plus 1. Now this limit is 1. We have already done it in this video, and this one we can just let h go to 0 because the denominator doesn't go to 0. So sine of h as h goes to 0 is 0, and the denominator is 1 as h goes to 0. So we would have the limit being equal to 1 times 0, which is equal to 0. So we have found that the limit as h goes to 0 of cosine of h minus 1 divided by h is equal to 0. And this is the blue limit. So if we summarize now, we have that the derivative of sine of x is equal to sine of x times 0 plus cosine of x times 1. So we have that derivative of sine of x is equal to cosine of x.